So this section we've been studying exponential functions, a times b raised to some power x. So we have a variable in the exponent. And for this example, I'm going to study natural base e. So remember, e is our irrational number. It's an important constant all throughout mathematics. Actually, it's probably the most important one other than pi. So e, if you were going to enter it in the calculator, is something like 2.71828. Of course, it keeps on going forever without any patterns. And pi, where does pi come from? Pi is actually equal to the circumference of a circle divided by its diameter. But we haven't studied where e is derived from. That's what we're going to do now. And it's actually going to connect our study of limits. It comes from Bernoulli, who was trying to find the limit as x goes to infinity of 1 plus 1 over x raised to the x power. And if you notice, let's try some values to kind of see what this function is converging to. If I were to enter 10 into this function, 1 plus 1 over 10, all of that raised to the 10, you should get something like 2.593 out on your calculator. So it's in the ballpark, not exactly 2.718. Let's try a larger value, because remember, x is getting closer and closer to infinity. If I entered 100 into this function, I'd get 2.704. And if I enter 1,000, I get 2.7169. So we're getting closer and closer to our value 2.718. So e is actually defined as the limit as x approaches infinity of 1 plus 1 over x, all raised to the x power. So we connected our limits with e. We can actually connect e with our study of series. So we can come to e from another way. We can do a series of 1 plus 1 over 1 plus 1 over 1 times 2 plus 1 over 1 times 2 times 3. So if you see the pattern here, we're just going to multiply in larger and larger number on the bottom, just by 1 each time. This will lead us to e as well. So a series can lead us, its limit will be e. Now to connect e even more globally, let's connect it with I. So remember, I is your imaginary number, the square root of -1, and pi. So what happens if I raise my natural base e to the I times pi? And just for fun, let's add 1 to that. Now this equation here is a famous equation. It comes from Euler, the same mathematician that gave us the symbol of e here. And the idea is what this equals. It actually equals 0, which is quite astonishing. If you're not amazed by this equation, you have no heart. E to the I pi is equal to -1. So think about that.